I saw you guys pointing at big piles of elk poop. What's the scientific word for poop? Scat. See this willow tree right here?
Yeah.
You notice that there's bark missing on the left side of it? Can you see that? Do you see that it's still yellow? So that tells me that it's very fresh. That bark has just come off of that tree. So what would eat the bark?
I know, porcupine.
I'm going to walk over to that tree, so let's walk over to that tree.
Oh, I see him! Porcupine! Awesome! Oh, wow, there he is!
An interesting thing here about porcupine. He's got everything he needs up there. His food is the bark. Good stuff. Is he safe from predators up there? Oh, yeah. His head is over here to your left, kind of peeking over. He's eating the bark right now.
Yeah, I see him.
What's the only thing that porcupine would need to come down from the tree for?
Water.
Water. And where's water?
Right there.
Curtis Creek. So when we're talking about water quality, does that impact the wildlife in the area?
Yeah.
If the water's polluted, porcupine comes down, drinks, it's going to impact the porcupine probably, right? What do you think those might be? Just go ahead and stop.
Coyote. No, those are deer.
The porcupine's tracks, they're like as big as my fist, and they kind of, it looks like it dragged along. Yep, it sees drag marks. What you're seeing here is not one paw print, you're seeing two. So what's got little feet? Squirrels, this is probably even smaller. Could be a weasel, but you do see the tail drag there as well. One of the main reasons that we're doing this water quality testing, the people that are interested in doing this are the wildlife biologists, the same people that we've talked to at the Predator Research Center, the same people that we've talked to up here at Hardware Ranch. They're very interested in water quality because of the wildlife that it impacts and also what's in the water that people care a lot about. Does anyone here fish? Fish.
Oh, yeah.
Yeah. So you've got fish and wildlife are impacted tremendously by water quality in these watersheds. Fish actually need logs in the river where it slows the current down and makes pools where they can rest and all those kinds of things. So we're looking at this watershed from the very top here where this porcupine lives all the way down to the confluence of the Logan River and out into the Little Bear where we canoed in the fall. What we need to find now is the best place to test this water. I need someone that would be willing to be a scribe. So put Curtis Creek, and our date is February 2nd. Curtis Creek is C-U-R-T-I-S. Can you hear me better now?
Yeah.
When we talk about sound, you'll understand why this amplifies my voice. What was our temperature this morning on the truck, by the way? 7. It got down to 7. Now that's Fahrenheit. What's the scale on this? Celsius. Okay, it looks like our temperature has stabilized here. And I'm going to say 7 degrees with a C by it for Celsius. We're getting this in the water now. We'll talk about the conversion in math. I think I've done that with you once, haven't I? How does the water look here? Does it look clean or does it look dirty? Clean. Would you drink this water?
Yeah.
How many would drink this water?
I was dying.
You were dying?
If I had nothing else to drink besides snow.
The water temperature is 1 degree Celsius. What would 0 degrees be?
32 degrees.
Yeah, 32 Fahrenheit or freezing. Now we have ice out here on the rocks. How could there be ice if the water's above freezing?
Because it's colder outside.
The air has been colder. At night, as we saw, it was 7 degrees Fahrenheit, which is well below 0 with Celsius. Oh, burr! Can you see the bottom? I'm going to try not to fall in the creek.
Yeah.
I really don't want wet feet today. So turbidity is greater than 60, right?
Yeah.
Water clarity, clear, milky, or turbid?
What's turbid?
Clear. Turbid is what we measure there. It's how murky, how dirty the water is. Water odor. Smells like a porcupine. No odor. Dead fish. Do you see any dead fish? What you're seeing on the rock is not algae, but some moss and possibly some lichen. Although lichen doesn't usually grow where there's that much water. Present weather. Clear, cloudy. Okay, cloudy. Past 24-hour weather.
I don't know.
What was it doing? Snow. How much snow do we have? 2 inches. So we need to do dissolved oxygen, the water depth, and the pH. These are pH strips. Now, being scientific, if I touch this end, if I accidentally grab that end, can I still use this sample? No, because it's going to tell us the pH of my fingers, not the pH of the water, right? So that's an important part of doing any kind of scientific study is you want to reduce what we call the variables, okay? What could taint or contaminate our data? So I'll go ahead and drop this in. I want to get out here where the water's flowing. And I'm going to pull that out. Do you want to match those up? Or we're just looking for the closest match. What do we want 2 people to look at the sample? Okay, it's kind of like when we do math and I have you guys compare your answers.
6.5.
Okay, if you get different answers, then we want to look at it and go, why did we get different answers? 6.5 is a pretty good match. So for pH, right, 6.5. What do our other pH measurements say? Look, 7, Logan River confluence. So our pH, our readings in pH, from clear up here at the top, all the way down to the end of the Blacksmith Fork River, are within a half a point. We're getting 6.5 or 7, is that right? And the last thing we need is dissolved oxygen. Do you guys remember when you went to the sewer ponds? Okay, and the sewage, when you've got that decomposing, that eats up dissolved oxygen. So I'll be curious to see. On Thursday, we'll do a reading below the meadow. Okay, now what's one thing that could be different about that reading Thursday?
The weather.
Will this same water be here Thursday? No, but it'll give us a good indicator of what's happening in this watershed. This is dissolved oxygen. The instructions say to have this 25 milliliters. By the way, when we were doing metric system a couple weeks ago, what is a milliliter? Milli means what? 1,000. Okay. So 100 of these, 100 times 20 is what? 100 of these, that's 20 milliliters. 100 times 20 is 2,000. So that would be a 2-liter bottle. All right, we need to drop this in. Dissolved oxygen readings in the past, we have an 8, 6. Going to break the tip. Where would you expect the water to be the cleanest in this whole watershed?
In the middle.
Well, here or down at the Logan River confluence. Why here?
Because it hasn't traveled as far.
Yeah, there's less things that could pollute it, right? So the end of this has a hole in it, right? Yeah. See how the water's not coming out? The air pressure creates what's called a vacuum. The water can't drip out because no air can get in there to fill the space. It's kind of cool stuff. And now we're looking for a match. So I'm going to ask you guys to tell me where you think it matches.
I think it's about...
Don't say any numbers, just tell me when to stop. This one or this one? That one?
Yeah.
Okay. Let's ask these guys. Tell me when to stop.
The one to the right. Yeah.
Which
Right
one,
there.
8 or 10?
10.
Okay. What did you guys decide? 10. So there we go. 10 it is, right? Dissolved oxygen 10. That matches our highest reading, right? Where was that other 10 reading? Do you remember? Does it say on there? I'm curious if that was down at the bottom or if that was up higher. So what we're going to do in March is we're going to look at all this data with some cool computer modules. Does it say Shinoa or Confluence? Okay, so our other highest dissolved oxygen reading was just below Hardware Ranch at the campground. So what does that tell us?
That up here is really good.
We're getting higher dissolved oxygen levels at the top of the watershed. Do we have a lot of data to back that up? No, but it's the first pattern we might be starting to see. That makes sense?
Yeah.
That's really what science is. We make observations, we write them down, and then we look for what? Patterns. You look for patterns. When we talk about snow science in a couple of weeks here coming up, hopefully there will be enough snow on the ground. It's all about making observations, writing that data down in a computer base, and then they look for patterns, and pretty soon they can say what slope angles are the most dangerous. What direction did the wind blow? Does that have an impact? How about how much the depth of snow that fell? All those things they've found patterns with, and they can put all that together, and I've showed you that hazard rating they give, the circle, the target. That's all based on all the patterns in their data. Before we get up and walk away, I just want to make sure we have all of our data, and we do.